So here's another type of function we can learn how to graph. This function is in vertex form. Vertex form is written of the form y equals a times the quantity x minus h squared plus k. All right, and a lot of textbooks teach this a little bit differently. I like to teach this using the idea of zeros. So I'll get into that in a second. The first step that we should know is that we can still decide what the picture looks like. We can do this simply by looking at our leading coefficient a once again. All right? So a, we talked about this with standard form. When a is positive, it opens up. When a is negative, it will open down. So the fact that our leading coefficient is negative 1/4 tells us that it's going to open down. And we can also discuss the width of the parabola, whether it will be wider or narrower. With the standard form example that I graphed, we saw that it was narrow if the leading coefficient a was greater than 1 or less than negative 1. It will be wider if that leading coefficient a is a number that is less than 1 or if it's less than or greater than negative 1. So it's got to be a fraction. If this number is a fraction, it will be wide. And I can kind of relate this to you as that this leading coefficient can either make it happen faster or slower, depending on whether or not it is a number larger than 1 or if it's a fraction. You can almost think of it as absolute value. If the absolute value of this number is greater than 1, it's going to be narrow. If the absolute value is less than 1, it's going to be wide. The second thing we're going to do, here's where I was explaining my ideas of zeros. If you look at where we have this x minus h in our original function and see how it's kind of connected to where the x plus 2 is, that's our adjustment left to right for x. If we actually, instead of starting at 0, start plus 2 over, our real 0 position would be the value that we could plug in there in that x minus h spot right in here that will make 0 just for that x minus h portion. So what we're going to do is we're going to say, let's find the axis of symmetry, which is exactly what I was just talking about. It's the value that we can plug in there in the x minus h part that will make it equal to 0. So here we go with x plus 2 equals 0, since the x plus 2 is in the location of the x minus h. And the value for our x, our real 0, our real starting point, would be negative 2. And again, this is a vertical line, our axis of symmetry. Okay? Third step, anytime you have an axis of symmetry, you know your vertex has to be somewhere on that line because it's your highest or lowest point. So we're going to substitute that value, x equaling negative 2, into the function and figure out where at for y. So we're going to get an ordered pair as a result of our axis of symmetry. So we're going to substitute the axis of symmetry. To find the vertex. And in this case, the vertex is really easy. That's why it's called vertex form. If we plug in 0, here, we're going to notice that this is going to just be 0 squared times the negative 1/4, and anything times 0 is 0, plus 5. So our result is really just going to be this k value over here. So our vertex is going to be negative 2 resulting in a positive 5. So we can graph that. This last step gives us one more value that we can plot and then also reflect. You'll see that we have really this y-axis wide open. So what we can do is we can plug in 0 for x to figure out our y-intercept. So I'm going to say let's evaluate the function when x is 0. Remember, if we plug in 0 for x, it gives us a y-intercept. So what that's going to show is y equals negative 1/4 of 0 plus 2 squared plus 5, resulting in the ordered pair 0, 4. 0, 4. Remember to follow your order of operations. Do the parentheses first, then the exponent, then multiply by the negative 1/4 and add 5. And you'll get 0, 4. 0, 4, again that y-intercept, and it can be reflected. So it's the same number of units to the left-hand side of the axis of symmetry, and plot that point. Now, generally speaking, this gives us the look of the parabola. If you want to be more specific, you can plug in more values here after step 4 to get some more points that you can reflect. I let my kids just use these two because it gives us an idea about what the parabola looks like. Opening downward and wider than normal, wider than what we would expect. I hope this helps you. These 4 steps can help you graph quadratic equations when they're written in vertex form, using the axis symmetry and functioning under the idea of our 0 value, what makes the inside of the parentheses 0.